Hello and welcome to this titration work question with an applied scaling factor. So reading quickly through the question, it becomes evident in the first couple of lines that they're describing a titration procedure. But the issue is there's quite a lot of different numbers coming at us in fairly quick succession. So it's quite important maybe to visualize what that actually means and what's going on before we start trying any calculating. So let's start with the first sentence where it said a student had a 250 centimeters cubed sample of sodium hydroxide. So 250 centimeters cubed is a normal sort of standard quantity that we use when we're doing titrations because it allows us to take samples from it and titrate each one. So quite often we might have to do a trial titer and then maybe 2 or 3 titrations before we get concordancy. So this will be our stock solution. Now the solution will be what we're trying to work out the concentration from in this particular case. So the next thing is that they told us that this was titrated against 25 centimeters cubed of a 0.1 mole per decimeter cubed solution of H2SO4. So that means that the sodium hydroxide in your volumetric flask is used to fill the burette. Obviously not the whole 250 centimeters cubed, but about 50 or a little bit more maybe. So you fill the burette up to about here. Now at the bottom of the diagram, you've got a flask containing H2SO4 plus the indicator, hence the red color. So what you're doing is you're titrating the sodium hydroxide and seeing how much of it takes to neutralize that specific amount. This being the 25 centimeters cubed and the 0.1 mole per decimeter cubed solution of H2SO4. So the titer was found to be 34.7 centimeters cubed. So that means that 34.70 centimeters cubed of our sodium hydroxide was used in that titration. Now obviously that's not the whole amount, is it? The original amount was 250. So they want us to find the concentration of the sodium hydroxide in the original 250 centimeter cubed solution. So we can calculate the moles of sodium hydroxide for our titer and then scale it up to find the concentration in the original. So one way of doing this is to use the data moles equation moles answer technique. So you draw an equation for the balanced reaction across the top, so the 2-to-1 mole ratio for your sodium hydroxide and H2SO4, and you insert the data for the substance which you have enough data for to work the moles out. So we have the volume for H2SO4, and we have the concentration for H2SO4. So the number of moles of H2SO4 is the volume divided by 1,000 times 0.1. So that gives us 2.5 times 10 to the minus 3 moles. Now looking at the equation, there's a 1-to-2 mole ratio between the sulfuric acid and the sodium hydroxide. So to get the moles of sodium hydroxide in our titer, in the 34.70 centimeters cubed, we need to double the number of moles of H2SO4. So that gives us 5 times 10 to the minus 3. Now we want the number of moles in 250 centimeters cubed of sodium hydroxide. So we take the number of moles that we've just worked out in our titer and we scale it up. Now the scaling factor involves multiplying the number of moles in the titer by the big volume over the small volume. So the big volume being 250 centimeters cubed and the small volume being the average titer. So that gives us 0.036 moles. So now we can work out the concentration as directed in the question. So the concentration is moles over volume. So that's 0.036 divided by 250 over 1,000. So that gives us 0.144 moles per decimeter cubed. So doing a quick mark scheme check, we can see that we've got Mark 1, Mark 2, Mark 3, and Mark 4. Okay, hopefully this has been a useful look at this type of calculation. Thanks for listening. Until next time, see you soon.